Well, I apologise. I got a stinking cold today, so the sound of my voice is going to be even worse than normal. I thought I'd do some odds and ends, tidying up loose ends, and very often these are ends up quite time consuming. What I wanted to do when I brought these buttons and switches out onto the into their new position on the machine, the press buttons is have lights in them. Now these lights are 24 volt bulbs inside. They're special bulbs, so I'm going to try to rig up some alternative 12 volt means, because we got 12 volt available for the machine lamp. I really don't know how well this lighting and zoom. I'm zoomed in quite a lot, so I don't know how it's going to go, but let's see what we can do. Basically what we got is that's the barrel of the button. That's how the button operates, like so. And if there is a sleeve on here covering that little bit of wire sticking out, it's a latch on, latch off. Now I want one operating as a latch on, latch off, so I've got to figure out how but I can use a bit of plastic pipe and split it, or whatever. I really don't know. I can't remember. I know one of them was actually switching, but I seem to can't. I've lost one of these switches. It's probably the one that does toggle, but I need a toggling for the turning on the machine lamp. What I want to do, as you can see, that the bulb stays permanently in there. The bulb contacts are these two, and there's a whole switching mechanism go on the back for the contacts for the switching. This is purely supply to the light. So if I try pretty slippery customer. I wonder if I can latch it. Yeah. Yeah. Oh, you see me breaking this one. Here we go. There he is. Well, that's a pretty specialised bulb there. It's a bit like one of those like Christmas type, Christmas tree type bulbs, but a very high quality one. It's got like kind of plastic end to it, chisel end, two embedded metal sleeves each side, and I think I'll use magnifying glass. Yeah, it seems to be it's cemented in the glass bulb. See the length of the bulb there. I'm going to end up losing this. Alright, you see the length of the bulb, so it must have wires coming out, press fit or whatever onto the metal, and it's held in by like a kind of a black cement. Just as a last resort, I did try it on 12 volts, but it was so dim. It was not really, couldn't go with it. Oh, it's moving. See that? That's interesting. I wonder if we can work this one out. Well, actually, I'll come to that one in a minute. We'll come back to that one. But because I want a switch, just having a light to turn on and off is one thing, but one of the lights, the red light in particular, is the low oil level light in the lubrication pump. Now that is just a two contacts, a float sort of sinks, floating on the oil will sink down until two contacts come together. Now that's not going to take very much current at all, so rather than a bulb, if I use a bulb I'll have to use a transistor circuit, a driver circuit, you know. So unless but if I manage to fit an LED in here, I've also gone through the options of grain of wheat bulb and so on the internet. I did have some years ago, but I couldn't find them. But we come back to this bulb problem, where you, at least for the oil morning light, I'm going to have to add yet another transistorized circuit to drive it, which I don't really want to do, unless it's necessary. So I've been digging out some LEDs here. That not is red, but it turned out to be a flashing one. That's not really what I wanted. I wanted it as white light. Well, these are clear, but when I fire them up, he actually emits red light. So again, that was no good. So I finally found, well, I didn't find, and what I've done, I've nicked these three LEDs out of my torch. It's like sort of, I don't know, there's about 10 LEDs in the circle on my torch, so I've taken out three to see if we can actually use these. I've unsoldered them, and I've got short legs. So first of all, will it physically sort of fit in? That's 4.94 mil. This glass bulb here is 4.64, very close. But if I remove that that black adhesive stuff layer, which seems to be like half a millimeter thick, then it probably will fit in. Will it clear? Yeah, it will actually clear. It won't rub on the switch at all. There is a small flange on the base, which I might have to cut or file away. Lengthwise, before we pull this bulb apart, I think lengthwise, if I rest him on the end of those metal poles, he is going to protrude forward, I don't know, a couple of mil, 1.5 mil, 2 mil, which may be too much, I don't know. Or I might be able to cut a bit of this metal away. I'm not sure how to actually. I'm wondering if I drill a small hole. Yeah. I'm just wondering if I drill a small hole here somewhere, that lead could go through and bend out at 90 degrees, which would hold that one in position on the end. Somehow slide a resistor in there somewhere. And will it solder? Well, it looks like steel to me. It probably will solder. But it's going to be a bit fiddly. And again, also, how do we decide what resistor value to use? Well, that's simply Ohm's law. If I use a bit of paper here, you know, if I say there's 12 volt, normally LEDs they got a forward voltage drop across the junction. Now the value of the forward voltage drop, it depends on the frequency of the light that it emits. A red LED is probably 1.8 to 2 volts drop, and to the other end of the spectrum, blue is about 3.5 volts, like, you know. So I'll stick with 2 for white. I don't want a high intensity light. I just want to energize it. And so to that aim, normally LEDs I'd stick about 20 milliamps through them, but we really don't want intense light, so I'm going to quarter that value. So we'll say we'll try 5 milliamps. So our supply is 12 volts. Our supply is 12 volts. Can you read that? Supply is 12 volts. 12 volts minus the 2 volt drop equals 10 volts. Okay. Now using Ohm's law, VIR, V over I equals R. Because our voltage is 10, and our current is 5 milliamps, so that'll be 10 divided by these 10s ones 0.005, which 1, 2, 3, 1, 2, 3. So that cancels out. So 5 in the 10 is 2. Bring up the 3 notes. That's 2000 or 2K. A resistor value. They come in series like E24 and E12 series. You would normally find a 1.8K, or what I would call 1K8, or a 2K2. I'll go for a 1K, or on the large side, so it's the lower value. Bearing in mind that I've already quartered the current that I normally use on them. So 1K8. If I didn't have any 1K8, I'd try a 2K2. So I'm happy with 1K8. That's what I'm going to go with. Right, our next problem, in my eyesight, isn't the best in the world. It appears to be open this end, the front end. What's going on here? It's bending right out now. Well, that wasn't very powerful, was it? I'm beginning to wonder now if that wasn't cement. I'm wondering if it was actually just rubber grip. It's a grip. We'll soon find. No doubt, we'll soon find out. I'll open this up now. Well, as suspected, I can't see a bloody thing. So I'm going to twist it and break this one out, off. Here we go. Okay. Yeah, a little bit careful there. Now. Right, my guess is it was probably spot welded in that region there on the inside, both sides. Now, if we use let's try using I don't know how this is going to work at all. I think if I trap that one in, if I take the flange off the base of this LED and drop him just inside the pores, it will give us our diameter back. If I drill a tiny hole there, I can bend this in 90 degrees, this leg, take it out through him and solder it on the outside, which will hold that in place.